All right. Okay. So we're a go. I'm gonna do a quick intro. Just for the people out there in the stream, there is a link for questions. So we will take your questions, and the stream will be streamed as you know, like last week, and we're also recording it, so you can see it. At the end of the talk, Brandon in the back, he will be passing around a mic so that you know, when you ask your question, everyone can hear it here, but more importantly, people on the stream can also hear the question, right? Thank you for coming to the Friday FUTO talk. You know, it's August in Austin, and we know that you could have enjoyed the weather outside, so many other things to do, and you're here. Really appreciate you being here, and tell your friends about FUTO lunch and the FUTO talks. We got, I mean, actually this month is filled up with talks. It's not every week, but we will kind of get into a cadence where this will be a regular thing, and it's going to be part of what FUTO does. And you know, if you want to know about other stuff the FUTO does, like go on the interwebs and look it up. Speaking of looking things up and introductions, I want to introduce the UBO project. And our speaker, who is flying in from Berkeley, California. So Mehrdad is the creator of UboPod, an open source, hackable, and multimodal personal AI assistant and self-hosting device. And I should say we met him at Open Sauce, which is great, like a couple weeks ago. If you guys have a chance to go next year. He holds a PhD in electrical and computer engineering from Rice, and his research focused on hardware security and privacy, kind of things that FUTO people are interested in. He's been developing and shipping hardware products since 2012, and prior to Ubo, he built BitLock, a Bluetooth bicycle lock with integrated mobile apps and management software. He's also one of the founding members of PicoVoice, a startup that's building voice edge AI products and on-device voice experiences. The links are on the slide, and on the internet. You can check it out. There's a Kickstarter, the Ubo project, getubo.com. Check it out. And so, without further ado, let's have some content here, and I'll stop droning.
Hey everyone, my name is Mehrdad. I wanted to first thank Aaron and the FUTO team for inviting me to this beautiful city of Austin. And I'm very excited to be here for this talk. And I hope you enjoy it, and I look forward to the questions and questions at the end of the talk. So I'm going to talk about Ubo project, which aims at building a class of open source, modular, and future-proof devices. So this is kind of a bigger project, and there are different manifestations of these devices throughout this project. So in this talk, I'm going to focus more on UboPod, which is the first manifestation of Ubo project. So a little bit of a background about me. I got my PhD from Rice University, not too far from here in Houston, Texas. My research was mostly focused on hardware security topics, anti-counterfeiting of ICs, and hardware Trojan detection. But I really wanted to build products that other people can use. So after graduation, I was kind of obsessed with the idea of using your phones as keys, with knowing about authentication and things like that. So I decided to build a Bluetooth-enabled lock, and I went after like bikes, and because I wanted to make a bike share system. It was my kind of first real hardware manufacturing experience, and I learned a lot of stuff about how to bring a hardware product to mass production, and it's a really challenging thing to do. And after that, I worked on several IoT projects, and I joined as one of the early members of PicoVoice founding team on building very efficient voice AI models. So I want to talk about my motivation for starting this project. So when I look at the devices around me, like around us, there are several things that has always bothered me. One is kind of like the lack of interoperability between these device ecosystems, and also the vendor lock-in effect. So when you buy a device from Amazon, it will only work with the cloud services of Amazon, or Apple devices only works with Apple ecosystem services. So it's kind of like limits the consumer in terms of the services that they can use with their hardware devices. There's also kind of the security and privacy concerns because the devices that we buy are black boxes. We don't know what is inside and how they're operating. And then there's this thing with especially IoT devices that there's like kind of planned obsolescence, and sometimes the vendors like pull the plug on the services, and your devices just break. You spend a few $100s on it, and it's no longer functioning because they don't want to pay for the hardware for the cloud services. There is also kind of like lack of transparency and closedness of these devices. Like you don't know what is inside and what kind of software they're running. And there's also the topic of repairability and upgradability that Louis Strassman also talks a lot about it. And it's, the devices are really not designed these days to be repairable. So they have kind of a limited shelf life. So you just have to throw them out when the new model comes out. So I wanted to kind of like in the UBO project, I wanted to kind of go completely in the opposite direction and taking kind of an extreme stance on all of these items and give the maximum flexibility to the end user of these devices. So I have this graph. I tried to put these different dimensions on it, but I wanted to kind of limit it to 2 dimensions. But I eventually came up with these like 2-dimension graph. So I would say one vector of this kind of the y-axis is hackability score. So you can give a device a hackability score based on several criteria. Is it repairable? Is it upgradable? Is it open source? Is it customizable? So if it checks all these criteria, you can give it like 9 or 10 out of 10. And then the other one is the kind of user experience. So when you look at all the hardware devices around you, generally the devices from the big tech companies, they have a good user experience. Like there's no denying of that. But then they're very, like they're not hackable. So like there's almost 0 amount of hackability. So you would give them like 0 or 1 out of 10 for hackability. On the other side of the spectrum, you have like these dev kits or DIY build kind of devices that are 100% hackable, but they're not usable. So it's just like they're usable by only like very few number of people who just built those devices. So I wanted to kind of like go in the quadrant in the top corner and kind of build some devices that kind of bring these 2 usability and hackability criteria together. So there are some classes of devices like framework laptops. They have done a good job in terms of upgradability and repairability. I can't say if they're 100% open source. They're open to some degree, but like you cannot go and look at the schematic or the layout of the boards. But I mean, it's a step in the right direction. But there are very few devices that have these 2 attributes of usability and hackability. There's also like Pebble Watch and Uno Watch that have tried to kind of introduce more hackability. So just kind of a quick overview again. So UBO project aims at building a class of devices that are open source, both hardware and software. So when I talk about hardware open source, some people, like some companies, publish their schematics of the electronics and say that's the level of openness that we're willing to make the hardware open source. But that's really not enough. For me, open hardware means you have the layout, schematics, and all the like bill of material, everything published. That would make a hardware open source. And software would be like all the code needs to be published. So the devices, UBO project aims to make devices that are modular and customizable. I'll go into more of the design aspects of these principles later. And I would like to make the devices feature-proof. So feature-proof means that like if something new comes out, you can just like upgrade a subcomponent. You don't have to like upgrade the whole device. So you can upgrade part of your device to make that last longer. So kind of like how the old computers where you just like you would upgrade your CPU, or that's kind of make the devices more future-proof. And I've taken also a UI and UX driven design, that means that every decision that goes into the design has to be put in from the lens of the user. So like, how does that improve the user experience? And so the first users of Ubo are developers. So that means that the approach is developer first. So I'm making these devices first for developers, and then once the experience is polished enough, a kind of like less tech savvy group of user could use these devices. They're powered by single board computers with a focus on privacy and security. So the first manifestation and implementation in the Ubo project is UboPod, which is an open source hackable device. It works with Raspberry Pi 4 and 5. It is designed for developers. It is modular and extendable. It has a sophisticated UI and UX. It is designed to make self-hosting of apps easier. It comes with a programmable AI assistant and an API, and it's upgradable and repairable. So I'm going to go through some of the hardware design decisions making UboPod and kind of explain how these like modularity, extendability, and things like that were included in the design. So this is the exploded view of UboPod using Raspberry Pi 5. So you can see there, right there, there's Raspberry Pi 5 and the heatsink. So the design is kind of stackable. So there's a board that goes under Raspberry Pi, which has the NVMe hard drive, or it can also take an AI accelerator. So it's a PCIe daughter board. And above that sits the top module, which includes most of the UI user interface logic. It has a camera. It has a sideboard, the board that connects to the Raspberry Pi from the side, and it brings all the connectors to the back. And it has like an aluminum enclosure. So the top module is detachable. So that means you can kind of like use a different top module. So it's like you pull it out of the device and you can swap in a different top module. It includes and encapsulates UI logic. That means so it has like a continuous RGB ring. So that's useful for like giving some sort of visual feedback, notification to the end user something happened, or like a progress wheel or a spinning wheel to show something's happening. It has a color LCD and a keypad, and with the software, we give user a graphical user interface. It's a simplified UI. It's not intended to replace a full desktop experience, just something that you can just go in, change certain settings on the device without having to hook up a monitor or keyboard or do SSH terminal to it. It has audio, 2 microphones, and 2 speaker drivers. It has IR receive and transmit devices, and also ambient light sensor and temperature sensor on board. So the enclosure is made of extruded aluminum. So extrusion is a technique that basically a big rod of aluminum is pressed against a cutout extrusion die, and imagine like a toothpaste coming out of like a hole. So this like long tube comes out of the extrusion die, and then these like big tubes are made in the factory, and then they're cut into smaller, shorter length and taken to the CNC machine for final processing in the finish. So basically, I can make different kind of devices within the same profile of the extrusion. So I can use this extrusion profile for making different types of enclosures. So it's kind of like a blank canvas for making enclosures. So I had a prototype made with this extrusion, which you see it's like a UboPod, but it's like a longer, and it has 4 SSD drives inside. It has 4 SATA SSD drives inside. It's like a NAS build. So it was kind of exploratory design, but as you can see, like I can use this extruded profile for making different kinds of different devices with different form factors. So that's the one right here is the extruded profile, cut to the length, and then this one is after CNC operation on the extruded profile. So remember I was talking about future-proof, making devices that are future-proof. So one thing that happened between Raspberry Pi 4 and 5, the location of the Ethernet port changed. So Raspberry Pi moved the Ethernet port from the left to the right, and that meant I had to do a different cutout of the CNC program for the enclosure. And I was thinking like, well, what if they change that again on Raspberry Pi 6 or something changes? Like, does that mean people have to come back and buy another enclosure from me? So I came up with the idea of like, I'm gonna do a big cutout here, and I'm gonna add a swappable panel. So if the port configuration changes in the back, people can just like swap it out with a different panel, and they don't have to like buy a new enclosure for the future device. So that's how it kind of like designing for future can work, can come into play. And it also helps me for prototyping. So if I'm prototyping a new configuration, I can just like build it, 3D print a backplate, and just like use that in the prototype, and it would accelerate my build. So I was talking about modularity. I showed the top module. So this is the sideboard, and I came up with the term HAS, which is hardware attached on the side. So HAT term is very established. People call it HAT, like a hat that you wear, and it stands for hardware attached on top. And like over the past few years, two other terms have come into existence. One is HAB, or HAB, which stands for hardware attached at the bottom, and then I came up with this one, HAS, hardware attached on the side. So this is a board that connects to the side of the Raspberry Pi, and it brings the ports to the back. And basically, it changes the mini HDMI connectors to full HDMI connectors, and bring the micro SD card reader to the back and the power to the back. So I'm working on actually a new variant of this PCB that converts one of the HDMIs to a USB-C video output. So you can actually connect a USB-C monitor with power. Without power, just it will get the power from the USB-C on the board. So it's like a single cable experience with this board. So you can imagine like this is again a module in the design. You can have different builds with different modules and different configurations. So this is the HAB, hardware attached at the bottom, and this is basically a PCIe adapter board. And you can attach an NVMe SSD drive, or I also designed an adapter board that kind of changes the pinout for M key to AE key, and I have a Google Coral accelerator, for example, mounted with this adapter, which has a different pinout. So it's like these are HAB boards or modules. So the front camera is also, you can mount different kinds of cameras. So there are these like 3D printed rails in the front that you can, like if you use a different camera module that has a different dimension, you can use a different rail to mount them. So it's like a very adaptable design that you can have for different. So for example, this is like a sensor from Useful Sensor, which is just a QR code scanner over I2C, and I designed a different rail for this one. So you can also connect sensors to this device. So it has two connectors here. One is internal, one is external. And for example, you can place a bunch of sensors inside the enclosure and close it down. So these are environmental monitoring sensors, like air quality sensor. This one is a PM sensor particle. It measures the size of the particles. And I think this is a CO2 sensors, and these are like gas sensors. So these are off the shelf. They can buy these from Adafruit or SparkFun. They have similar connectors, so it's basically 4-wire sensor, and you can daisy chain them and put them internally and connect them to the connector inside. Or if you want, you can connect them externally. So I added two connectors. One is internal facing, the other is external facing. So if you want everything to be tucked in, you just put them inside and close it. So you can just come up with your own use cases. It's very easy to connect a sensor. And now on the software integration, we're making this plug and play, especially with Home Assistant. So you can just plug in an air quality sensor, and in Home Assistant, it will just show up, and then you just add it, and the data starts coming into the dashboard. Okay, so a lot of talk about the hardware. So let's talk a little bit about software side, because a hardware with no software, I would say, is a potential without realization. So the software part is as important as the hardware part. So on the software side, we spend a lot of time on building the graphical user interface. So the architecture of the graphical user interface, so the display that we're using is just a TFT display, and it communicates through SPI bus. But then we wrote this library that helps Kiwi, which is an open source Python framework for building cross-platform GUIs, to stream over SPI. So we had to develop that kind of like thin layer over under Kiwi, and then we developed these like widgets specific to GUI. So we needed to have like a menu widget, kind of these gauges or things like that, and those go inside Ubo GUI library. So these are the path for the GitHub repositories that you can check out these libraries. So basically, Ubo GUI are custom widgets that we defined with Kiwi Canvas. And what Headless Kiwi does is that it kind of streams the video over SPI so that we can show this on SPI driver, on it, like on the LCD. What can you do with the GUI? So on the GUI, you can monitor system resources. So with a quick glance, you can see how much is your CPU is being used, how much is the memory usage, how much is the disk usage. You can monitor other parameters like CPU temperature or things that you want to get a quick idea by just looking at the LCD. You can go into the menu and enable and disable SSH access. You can set up Raspberry Pi Connect or VS Code Tunnel for remote access. We have also set up Pangolin and TwinGate for setting up easy setup of egress. So a lot of people do self-hosting. They need to access the services on their home network from outside. So for that, they typically need to set up something that is known as egress. That means like externally, access services or resources on your internal network. And Pangolin, which I believe also received a grant from FUTO, they have a very great product, and we've done integration with them. And TwinGate is kind of similar, but Pangolin is a reverse proxy. TwinGate is more like a VPN. And you can use the GUI to get the IP interfaces of your interfaces and also the host name. You can install apps using the GUI. I'm going to show a quick demo at the end of the talk for the capability of the GUI. And you can also do user management, delete a user, reset password for a user. And we also show notifications on the GUI. So, and the notification can have sound, and it can light up the LED ring and also show a text on the screen about what the notification is about. And you can also navigate file system with the GUI, so you can actually go to the folders and open files or delete files. You can open images and it show it on the GUI. It's a tiny GUI, but LCD display. So the GUI itself is a standalone module. So I'm working on this kind of design that you can rack mount it. So a lot of people who do self-hosting of apps, they have these like mini racks or mini servers in their homes. And so I designed this this kind of like form factor and kind of refactored the GUI into this enclosure that is rack mount. So because the enclosure form factor doesn't really work well for people who host in racks. So it is kind of a rack mount GUI design. And I'm also working on a USB version of this GUI down the road, so you can just plug it into any computer with a USB 2.0 port, and it the SPI data goes through USB, and then it shows up on the LCD. So the Figma board for all the GUI design is also made open source. So for people who want to design new experiences, they can go and borrow some of these design ideas and kind of come up with a new kind of design on the Figma board. Going from Figma to kind of Kiwi implementation is fairly straightforward. You need to understand like the canvas and the drawing and stuff. It's not too hard, but it is very doable. So one of the philosophies in the design was that we didn't want to make hardware an artificial barrier to entry. So because of that, we decided to emulate the GUI inside the browser. So even if you don't have the hardware, you can still run the software on a bare Raspberry Pi with no additional hardware and use the graphical user interface. We also actually sent the audio through the browser, so you can hear the audio through your phone. And we have plans to basically connect WebRTC so that you can send your camera or microphone streams through your browser, so you can have a hardware-less experience as well. So the idea with the hardware is that if you need like a dedicated device that have those functions, but we didn't want to make that an artificial barrier. And so this streaming actually happens over gRPC web. So I'm going to talk about our gRPC API in a bit. So for this project, we had to actually, we decided to implement Redux in Python. So there was no clean and good implementation of Redux principles in Python. And the reason we decided to adopt Redux was so Redux is ideal for cases when you have like a complex system, and it helps you kind of with debugging, because there is a single source of truth in Redux, which is your store, which stores your application state. So every store snapshot gives you a global view into your application space. So you can actually do time travel debugging with Redux. You can just like go through different kind of like steps, how your application state is changing and back and forth, and then kind of say, oh, okay, here there is some anomaly in the state kind of not updating. So it made it easier for us to kind of manage these like complex system interactions. So in the core architecture, we have this kind of reactive Redux bus, and different services dispatch actions to this bus and listen for events. There's also kind of like a auto run capability. That means you can say, monitor the application state for me, and if something changes in the application state, run this function for me. So we have like these decorators that you can set up in the code and say, if this thing changes in the application state, then auto run this function. So this is actually a very complete implementation of Python Redux that also handles side effects. So for people who are familiar with Redux implementation with React, typically for handling side effects, you need to install middlewares like Redux Thunk or Redux Saga. But for this, we implemented that, and it natively handles side effects. So just like now that we are here, we also integrate with dbus and Linux. So all the kind of Wi-Fi management, Ethernet manager, Bluetooth, and everything connects with Linux dbus, and also the user and system management. We have a Docker manager, which basically uses Docker Python SDK for automatically like installing a Docker container, running or stopping or fetching the image, or all the Docker operations. And yeah, so everything basically communicate with this like Redux architecture. And then we expose that Redux kind of reducer functions or things that are defined in the system, we expose that through a gRPC API. So you can actually remotely send these actions. So like gRPC is listening on a specific port, and you don't have to be on the same network. You can have one of the services on a different device that would communicate remotely. So this shows how easy it is to install a Docker Compose or Docker container using the web graphical user interface. So you basically go on the ubo name, which in this case is ubo-pz.local, and then the port is 4321, and then a form pops up, and then you enter your Docker Compose and the information there, and then you press provide, and it just like fetches the image and installs, in this case, Jupyter Notebook. For some of the applications, we're going to have these applications pre-installed or like pre-integrated, so you just have to fetch that down, like just start the Docker container. So I'm going to talk a little bit about the AI aspects of this. So we integrate with PipeCat. So PipeCat is an open source framework for voice and multimodal conversational AI. And basically, we send the audio frames, video frames, and the text frames from our core kind of bus, our like redux bus, to PipeCat pipeline. And also, we do the API key management. So for example, if you're using OpenAI, you need to enter an API key. So we provide the web UI and say, enter your API key here, and then we pass that to PipeCat so that PipeCat would have the access to the OpenAI API key for the cloud-based ones. But you can also run local models on Raspberry Pi 5. It's not very capable you cannot run very large models, but you can run 1, 3, or probably 7 billion parameter models on Pi 5, depending on how much memory you have. And PipeCat is a very capable pipeline, so it can do, like, it's kind of like, it connects all the AI models into one pipeline, so you can do image to text or text to image or text to text, like all these kind of conversions. And it works with pretty much every model that exists out there. And it makes integration and support for a variety of models much easier. And it also connects with Ollama, and you can run models locally. We also support Home Assistant, so you can set up UboPod as a Wyoming voice satellite. So that means it gets the voice and sends it over to Home Assistant instance, and you can have different UboPods in different rooms and talk to it, and then you have a centralized Home Assistant hub that receives the voice from these different satellites and responds to it. And we expose all the sensors on device to Home Assistant as well. We are also integrating with MediaPipe, which is an open source framework by Google, and it is ideal for classical ML machine learning problems like face detection or gesture detection, skeleton detection, kind of more classical AI operations. And I'm also talking to a bunch of companies to see if we can source AI accelerators that will kind of offload the operations from the CPU into a dedicated AI accelerator. There are 3 companies that I'm kind of talking to and see if this is kind of earliest stage, but DeepX is a Korean company, Halo and Edge Cortex. These are 3 companies that are on my radar that are making LLM AI accelerators for LLMs or large language models. So these accelerators, they have dedicated memory, so you don't need to have a lot of RAM on your Raspberry Pi anymore. So they put the model on the RAM that exists on the module or the accelerator. Some of them have 16 gigabyte of RAM, so it's like a dedicated RAM. How am I doing in time? Okay. Okay, so we exposed the gRPC API. The nice thing about gRPC is that you can write your code in any language as long as you kind of import the formal definitions of the API. You can call this API from any language. So you can write your code in JavaScript, or you can write it in Go or Rust or whatever language is your choice, and then you can communicate with the system through that bus. So basically, in gRPC, there are like these formal definitions of protocol buffers that say, this is my function, these are the inputs, and these are the outputs, like very formal definitions of those. And basically, you can call them from any programming language. So it kind of opens it up for people who want to interface and integrate with the device in a different programming language than Python. So you can dispatch actions. For example, you can say, show this notification on the LCD screen with this text, and with this, read this text with the audio and flash the LED ring green 3 times. And you can like easily dispatch an action to the API, and it'll do that for you as you describe it. So a little bit of a shameless plug. So I'm actually launching this product soon on Kickstarter. So I have the pre-launch campaign page up, and you can find more information on the website as well as on the Kickstarter pre-launch page. And feel free to reach out to me. I had my email, I believe, on the first slide if you have any questions about the product. I think that's pretty much it. And this is like I put this in appendix. This is the exploratory design that I did for a NAS. So there's like 4 SSD drives. So it's just like a long neck UBO. It's like giraffe UBO. And takes 4 SSD drives inside. So I do these kind of exploratory projects from time to time to kind of explore the design space. So people who kind of do programming or design, you always need to kind of explore a little bit and see like what are the possibilities that you can do. I'm gonna keep the talk, stop here, and then go to Q&A, and then after that maybe I do some demos, or maybe I do the demo real quick here. Yeah, let's do a quick demo. Oops. What happened? Oh, here. So this is actually a device that I brought online. It's connected to the Ethernet cable over there. So, so it's basically, this is the graphical user interface. So I can go here to apps. So this is the one I was talking about. If I press import YAML file, here I can say I want to install image, and then paste the compose file here and give it an icon. So we support the nerd icon, basically standard. And then you can set up an instruction here like access on port, was it 23? 2283. So this will be shown to the end user. And then you can also, if you need any .m file or any extra files, you can also attach it here. But I have already done it for image. So if I go down, I have image here. So like image is already running here, I can stop it. But if I go here, if you look at the URL, this is the image instance that is running on this device. So I put some photos on it. And if I go back and stop it, it won't load again. Start. Yeah, it takes some time to load. Yeah, so we're probably going to have image pre-integrated so the user doesn't have to install it. There are some complexities because we have to come up with a random password for the PostgreSQL password. I don't know, we have to think through the user. journey, and then maybe show them the passwords, like write it down somewhere. If you lose your, like something happens, you have a backup of your password or something. But that, some of these, self-hosted services are going to be hard-coded into the experience, and it's gonna make it much easier. So if I go to settings, network, Wi-Fi, you can add Wi-Fi with the GUI. So here it gives me two options. It's gonna start talking. Let me increase the volume. You hear the sound is coming from there. It's okay. We're gonna hear it. It's gonna be loud.
You can use either camera or web dashboard to enter this input. Please choose one by pressing one of the left buttons.
That's all right. So it's just like it reads out the text for accessibility. You can turn this option off, and then if I go to camera, it's not going to show the viewfinder here, but on the device you can see the camera, and you can hold this QR code to scan the Wi-Fi password. Or if I can go here,
you can use either camera or web dashboard to enter this input. Please make sure you are on the same network by pressing.
It's okay, we don't need that. So I can enter the SSID and the password and then connect to Wi-Fi. Going back to home. You can set up remote access. I can turn off SSH. I think I'm connected here with SSH. Let me just turn it off. Stop. Am I going to get kicked out? Probably not. Probably not going to. Yeah, so it won't let me connect again, like it says connection refused. You can set up RPI Connect. So it's actually, this one is actually running. I'm going to sign out, sign in. So it shows you a QR code. You scan this QR code, and then it takes you the Raspberry Pi Connect and authenticate you. I can actually do it real quick. So it's like logged in now. And then from there, you can actually access your device. Yeah, so it's kind of a quick overview. I don't want to bore you guys. And then on the hardware, you can enable IR. So this one is receiving, like, you can disable, enable IR, receive, or propagate. So we're still kind of polishing this. This is still kind of work in progress, but it's probably going to be in a way better polished state before it goes out. All right. I think we should wrap it up.
All right, if you guys just want to raise your hand, I'll walk around with the microphone. Anyone have any questions?
So, very interesting presentation. Thank you for it. I'm curious. I was looking at the UBO website, your Kickstarter,
Yeah.
and this is like a lot of work. I'm
Yeah.
curious. Is it just you? Do you have a team behind it?
Yeah, a team of 2 people. Yeah. Basically, this project has been in the works for a couple years now. So so it kind of progressed over time. Some of these things kind of like was part of the things that I did in other projects, and I kind of brought them together. But I would say like this has been in the works for maybe 3 or 4 years now, but like not like I wasn't working on it full time during those 4 years. Maybe like half of that was kind of full time. So yeah, a lot of work has gone into this project, especially the hardware side is very heavy lifting stuff, because with all the manufacturing and supply chain and now dealing with the tariffs and stuff is quite challenging.
So that was actually my follow-up. So with the hardware side of stuff, so open sourcing it is very important, and
Yeah.
the open hardware has some increased momentum behind it, which is cool. Are you also aiming for any particular sourcing constraints or advantages? Like, are you okay just sourcing everything from China? Are you trying to make it locally accessible? I'm curious if that's part of your calculations.
Yeah. So the thing is that I already have, so I took kind of a different approach with sourcing. So basically, when you go about like sourcing and buying stuff, the way I look at it is that I usually buy components that are cheap, and I know I'm gonna need a lot of them in advance, and then wait on buying the expensive components. So I have the parts that kind of like, I would say 80% of the subcomponents in inventory in US right now for kind of a decent number of kind of units. And then I still need to buy the high-risk components. So high-risk, not necessarily too expensive. So the top module, I haven't made a lot of the top modules because the top module is a sophisticated part and the design might need some refinement. But the enclosure is something that I have in inventory. And actually, aluminum is a bit tricky now with the tariffs. And the good thing is that like I've had that, like did the import them like in last year for the enclosures. But it's going to be definitely a challenge for going forward. I'm thinking about like moving maybe some of the electronics manufacturing over time to Taiwan or other locations. In US, it is also possible to set up some sort of like pick and place machine and do it locally. But good pick and place machines are like 50 grand-ish. So if you're making maybe 10,000, 20,000, it might be worth doing it. But at lower volume, it's a bit challenging.
Thank you.
Yeah.
Yeah, thank you for coming out. You talked about this being developer first and focusing on them. Do you have like a longer term version for bringing this to people who say like don't know what Docker is, expanding beyond developers, or is that where you want to focus for the foreseeable future?
Yeah, the end goal is kind of like gradually move this toward the user profile that, as you described, like they don't know what Docker is, or they want some like kind of polished journey, basically making it more plug and play. And as you notice in the image example, like if the image is already installed, all the user needs to do is to go to apps, image, start, right? So it's a three-step journey. And for the Wi-Fi, adding Wi-Fi is a very, like you can just hold the QR code and add Wi-Fi, you go through the web UI. But let's say the user wants to do something more complicated, then the journey also gets more complicated. So if the end goal is simple, like I can make the journey simpler. So it's something that I have, like it's something that I'm gonna learn through this journey to see like what are the most requested feature that people want out of the box, and then refining those experience for the kind of the average consumer experience, and then kind of hiding more advanced features in a sense that doesn't confuse them. So it's very complex, and not having those data points is even going to make it even more challenging. So like, and also I think this device offers more value to developers initially than to average consumer, and then as time goes by, we can kind of like double down on areas that we find out by talking to people.
Anyone else have a question?
You mentioned adding other like modular sensor devices like air quality, I would imagine like humidity. What else do you have on the roadmap as far as like use cases for the future?
You mean regarding sensors or in general?
The whole user experience. Are there other sensors that are packaged into that modular pluggable interface that you can imagine swapping in?
Yeah, so there's a large number of, let me go here. I have a discussion on this I made a big list of the sensors, so, oops, sorry. So I made a list of all the sensors that kind of you can buy. There, like different temperature sensor, humidity sensors, pressure sensors, gas sensors. There are motion sensors. I don't know what the use cases would be. Maybe you want to get notified if somebody moved your device. Or there are different light sensors. There's distance sensors. There's time of flight sensors, sense like a infrared laser and then gets a reflection of that and estimates the distance. That can be used, for example, if you want to know if somebody walked in front of your device or something like that. You could use like time of flight for like using like crowding, sensing crowding. Like if a lot of people walk in front of your device, that means like the place is crowded. But if you get like one person walking in front of the device once in a while, that means there's fewer people. But these are basically developer use cases. So you have to kind of like, it's not just plug and play use case journey. You have to kind of like come up with an idea. But the idea of having the sensor plugged in and get the sensor reading out, that part is going to be taken care of. You just need to tell the device what is the address for this sensor, and then what are the data that you want, like what are the parameters that you want to read from the sensor. And then these are some special magnetic sensors, or it can be also ADCs or some other, I've seen these like haptic motors that you can do to do vibration, so you can have your device vibrate. I personally don't like vibration. I always turn it off, but some people may want to have some extra, that vibration effect on the device.
Any medical devices integration that you are intending to do? Any kind of sensors, like Fitbit, but more extensive that you would consider integrating into this?
You can always like connect sensors with over radio, like if you have like a Zigbee sensor or something that sends data over Bluetooth. You can, because Raspberry Pi has Bluetooth, and this would be again kind of like a developer thing. So it's like part of this is that like we don't want to like do all the use cases, right? So like this is kind of left to the developers. Like so we're kind of like the middle layer. Like we're gonna make it easier for developer to plug this sensor in, and then after that is kind of what you want to do with the sensor readings is up to you. But in the medical field, this can be probably used for some sort of like researchers in a lab to come up with some sensors and connect to it and then start kind of like getting the readings. But from a consumer, I don't know, it's probably not going to be feasible in the near term. Like we're not going to go into a medical device category.
Are you familiar with Seed Studios?
Yes.
Okay. Are you doing any integration with...
So Seed Studio has like Grove sensor, GROV, which is the same as the Adafruit, Quick. These are different connectors. They're just 4-wire sensors. So all the Grove sensors from Seed Studio, you can connect to this and get the sensor data into Home Assistant or just like start kind of doing the readings.
Thank you.
I have a question from the live chat. And the question is, have you thought of using a BeagleBoard instead of a Raspberry Pi for tariffs reason, or isn't the UK a problem?
I don't think Raspberry Pi boards are affected by the tariffs. I mean, as far as I know, they're still the same price. So the prices may go up a little bit, but so far the prices have not been affected by the tariffs. And then for like if you want to run AI models, Pico devices are not capable for running large models. And even for self-hosting, you know, like if you want to like running image, it maxes out my CPU when it's doing the machine learning part, like when it's indexing the images. After that, the CPU usage goes down, but you need a capable CPU for doing the machine learning and stuff, for self-hosting of image or similar applications.
Any other questions? All right, I think we're good. Cool. Wanna close this out, Steve?
Thank you so much. Thanks, everyone.